let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am Andrew Sullivan, co-hosting as always with the amazing, wonderful, and not at all spooky Mr. Jonny Rickard. How are you today, sir?
That's right. I'm working on the spooky. I've got like the mixed beard going on right now. I'm gonna like try and like shave little designs in it to scare people. You know, that's the goal.
Now I'm curious. Are you actually going to dress up for Halloween? I mean, Halloween is next Tuesday, so.
So my daughter's got this. I don't know what kind of costume it is, but like I had the wig on last night. It's like black and orange, and yeah, it's not a good look. So I don't know if I'm actually gonna dress up, but like that was a good indicator that I'm not meant for long hair. So
I mean, so far as you know, right?
Well, yeah, according to me.
No, I found out my oldest informed me that he does not have school the next day, November 1st. So he's like, I can just stay out and collect candy. You know, he's 16 now. So he's like, I just stay out and collect candy until everybody turns off their porch lights. I'm like, I don't think that's a good idea. I think that's probably a bad idea. So,
But I like where your head's at. Like,
I mean, you know, that's exactly what we need, right? Is pounds and pounds of candy and sugar in the house, because
all hopped up on Snickers. Yeah.
Yeah. So today is the last stream, number 4 in our security series here on Ask an OpenShift Admin, and we are joined by the always wonderful Jaafar Chraibi. I apologize if I'm pronouncing that incorrectly. I am terrible with names, Jaafar.
No worries.
So I don't know if you celebrate Halloween over in France. If you do, then I don't know if you've got any plans coming up.
Yeah, I mean, so hi, Ron, Jonny, nice to see you again, Andrew as well, and hi to everybody who's watching. Yeah, so we do celebrate it as well, but it's not, I would say, as big as in the US, but kids are gonna dress up and go collect the candies. But that reminds me of like an anecdote that happened to my son when he was, I think, 2 years old or something like that, and one of the neighbors knocked at the door, and he was dressed as a werewolf, and we didn't expect that. So my 2 years old was screaming like crazy because he didn't get like a notice before.
Got him.
I don't know. Here in the U.S., it seems like the big ones are all they're not national holidays per se, but they're adult themed drinking holidays.
Yes.
So
Yeah.
Those are the ones that people usually make an unofficial big deal about. Halloween, it's all about kids, so we have fun with it.
Oh yeah.
Yeah. So Jaafar, if you don't mind introducing yourself, and then today's topic. This is something that I know you've been working with and working on for a long time, so it's something near and dear to your heart.
Yeah, sure. So thanks again for hosting me today to talk about this topic. So my name is Jaafar, and I work as a tech marketing manager for OpenShift. I've been with Red Hat for about 7 years now, and I'm very lucky to be working in Andrew's team actually. So so it's a good I would say occasion to co-present with you in here. And today we're gonna be speaking about software or trusted software supply chain, or CI/CD pipeline security. And I've had the pleasure of working with Jonny as well on all of those topics that we're going to be presenting. So basically the idea here is to understand how we can introduce security in the DevOps or DevSecOps approaches and prevent malicious code from being shipped into production within your applications and such things. So we're going to have a brief presentation of the different or the key topics, and then I'll be showing you a demonstration using our OpenShift Platform Plus solution that puts all that in play very nicely to help you implement a trusted software supply chain for your applications.
Yeah, and there's something I really like about this whole concept. Jonny was saying this before we started the stream of this is sort of the culmination and everything coming together of the last several weeks worth of topics as well as a bunch of other things. I think it's one of the most effective and really interesting demos that we have that showcases all of the components of OpenShift Platform Plus. Everything is running on OpenShift, and we have ACM for doing cluster management and cluster configuration. We have ACS for doing runtime security and security scanning and analysis. We have Quay that's doing the same thing as well as hosting all of those container images, right? And I assume there's ODF baked in there somewhere, probably acting as an object store or something like that. So it really brings all of those components together to show why we care about OpenShift Platform Plus in a very tangible way. So I'm excited about it. I'm really happy to showcase this one.
Cool. Yeah. So yeah, I think it's a great way of putting the pieces together. So basically, you have several tools that do great in their own, but when you combine them, you get I would say the bigger picture and a greater coverage of your end-to-end process. So it's security combined with all of the value that we bring with the other tools.
Absolutely. So before we get started with all of that, we'll quickly go through the top of mind topics and stuff like that. So as a quick reminder, this is one of the office hours series of live streams here on Red Hat Live Streaming, which means that we are here to answer whatever questions you may have about anything OpenShift related. Jonny and I have been administrators. We've done a bunch of different things inside of the OpenShift, Red Hat, etc. world. So we are happy to do our best to answer all those questions. If we don't know the answer, which I don't know a whole lot anymore, but Jonny's pretty smart. We know who to reach back to inside of the organizations, whether it's product management or engineering or wherever it is, so we can hopefully get those answers while we're here on the stream. If that doesn't happen, though, you can always reach out to us directly. You can see Jonny and I have both started including our email addresses in the little tags for our windows there. If you're not watching us live, if you're listening to us or watching a recording, it's very simple. Sully, S-U-L-L-Y, at redhat.com, or Jonny, J-O-N-N-Y, at redhat.com to reach us at any time. And we love to hear from you. Don't hesitate to reach out, send us an email, ask us questions. We'll track all that down and do our best to get you answers. That being said, today here on the stream, as Jaafar pointed out, we're going to be talking about software supply chain security. Feel free to ask any questions you have in the chat, both about that topic and about anything else OpenShift related. Again, we'll do our best to get those answered, whether or not they relate to software supply chain. And with that, Jonny, what have we got on top of mind today?
Just to go over the schedule for the next basically month, right? I mean, so running out of time, running out of weeks to stream, but this is the last episode in our security series, and then on the 26th, there is the OpenShift What's Next session. So that's tomorrow at 10 a.m. Eastern. So if you want to know what's planned to be released on OpenShift in the next, couple releases, I think it's like 2 or 3, something like that. Then make sure you show up for that tomorrow. It'll be live streamed. Andrew, myself, I don't know if Jaafar will be there, but definitely Mike will be there to answer questions and stuff like that as they come up. On the 1st, we're going to have etcd. So we're going to talk to some of the engineering group folks behind etcd, and we'll be able to ask a bunch of questions about stuff like backups and stuff like that. On the 8th, there's not going to be any stream because of KubeCon. On the 15th, Andrew and I are going to do an OpenShift 4.14, just kind of like a deep dive into what's coming out with it. On the 22nd, it's a U.S. holiday, which is Thanksgiving, my personal favorite holiday, actually. And then on
you
the
are both fat kids at heart, Jonny.
Dude, I love it. I'm so happy. I cannot wait. That's like I'm getting hungry right now just thinking about it. And then on the 29th, we have ACM, and this is going to be an awesome one. They reach out to us. They have a lot of stuff that they're doing with Zero Touch, and just all kinds of things going on. So it's going to be super exciting to have them here. And then on the 6th, we're still working out a topic, and on the 13th of December is going to be our last stream of the year because both Andrew and I are going to be taking PTO, and just gonna be rolling into the new year, nice and refreshed.
Yeah, yeah, or after all the holidays, literally rolling, as the case may be.
Yeah, I'm going to be pushed in. Yeah.
No, it was funny. We were chatting about that this morning. Chatting in Slack, and I pointed out that we only have 6 streams left for the rest of the year.
Yeah.
Hey, time flies when you're having fun. Seems like just
Indeed.
yesterday, it was we were celebrating the start of 2023, and here we are, basically 2 months away from 2024.
Yeah.
Just crazy.
And it's been a full year. It's not like it's been, just. I mean, we have been a little scattered in some months, but for the most part, it's been a full year of doing this. So
Yeah.
it's nice.
Yeah. Let's see. So other things that we've got on the list here. So the Summit 2024 call for papers is still open. I would definitely recommend that anyone who is interested in submitting a topic over into that, go ahead and do that. So it is in Denver next year, in case you didn't know, which is something that I'm looking forward to. I think I've said this before, back when the summit this year ended. I love Boston. I like San Francisco. Las Vegas it's Las Vegas. I'm tired of going to those 3 cities for everything. Every once in a while we'll have a Dallas thrown in there or an Orlando thrown in there or something like that. Denver is a city I haven't been to for a conference in a long time, so I'm really excited about it.
Yeah.
And I know the Red Hat folks that are in that area are also excited about hosting everyone. So super happy, super excited to be able to go to that.
If they got good beer, they got good microbreweries there. They've got good restaurants. Nice restaurant at the airport if you're going to be waiting through TSA. So
yeah.
They get
No, I
right there.
was out there recently for a customer visit and had a lot of fun while we were out there. So yeah, Lester, yeah, I like it out there too. Turns out that it's pretty nice. Let's see. And the other thing that we had on here, there was a blog post that published literally yesterday for the Windows machine config operator. Paste the link for that into here. So the big news here is with Wimco 9.0, there's going to be some changes that are important, particularly if you are running on VMware vSphere, if your cluster is deployed to vSphere. So be sure to, and I don't know if I can share my screen here. I didn't test this beforehand, and if you can't tell, I'm in the office today, so everything is different. I don't have my normal amount of screen real estate to work with. I feel cramped. Let's see. We're going to share this guy. So here's the blog post that I just linked out to. So as you scroll down through here, there's a couple of interesting things to point out. So CSI migration is probably the biggest one. And this is what we're going to be talking about with 4.14 as a whole, is CSI migration with vSphere. So if you are using OpenShift on vSphere with Windows nodes and the vSphere CSI driver, yes, I feel like that's a mouthful. It is a mouthful, but just pay attention and read through all of the different directions, instructions, etc. This blog post is just a precursor to documentation because your upgrade procedure is going to be a little bit more involved. So the background story here is with 4.14, OpenShift 4.14, the in-tree PVCs are going away. Automatic migration to CSI is enabled and is enforced. So when you go to 4.14, if you are upgrading from 4.14, it will migrate all of those volumes. And there's just some extra steps that you have to take if you're using Windows nodes inside your cluster. So pay attention to that. Make sure that if, regardless of whether or not you're using Windows nodes, pay attention to vSphere CSI and vSphere in-tree volumes. If you're not using in-tree volumes, you're fine. If you're deploying new clusters on 4.14, you're fine. If you still have, and if you want to do manual migrations from in-tree to CSI, that's fine. You can do that in 4.13. Just pay attention if you allow it to do those as a part of the automatic upgrade in 4.14. And I think that was our list, wasn't it, Johnny?
I have one more, and it's just
Okay.
a shout out to the OpenShift Commons. Is they're presenting literally right after this one, and they have the Microshift team on, or the Red Hat device edge team that's gonna be out there doing a demo and stuff like that. So if you want to check it out, here's the link to the meeting notes, and it should have the link to the the G Meet and all that stuff that they use. So go check it out after this one, of course. stay the full time for this one, and then go check that one out when you're done, because they've got some good stuff going on over there.
Yeah. Our Hope 9, I guess it's from 1.27. I know one of the Kubernetes is like one of the versions, it does get pulled out. I don't remember which one off the top of my head, but yes, they are very much related, and that's why we're going through that process. So, plus, the CSI drivers are generally much more featureful and just a lot of other capabilities there. So, yeah, I'm not sad to see us move that way, or Kubernetes as a whole move that way.
I think this release 2.4.14, they're going to have the API deprecation for the storage API too, where it's going from beta 1 to beta 2 or something like that. Like it's a small change, but there is an API. I'll find it and post it.
Okay. Yeah, we should probably poke at that at some point as well in the next couple of weeks, Jonny, of reminding folks how to find deprecated APIs that are being used by their cluster and how to plan for that.
Mm-hmm.
Nothing else we can dig up the blog posts and the other things that already exist on that, but it's an important one. So, some secure supply chain in action. Likewise, it's one of those things that it's been talked about. I think a lot of people talk about it at a ephemeral level, right? Hand waving and stuff like that. Jaafar has an actual demo that show. This is one, so a little behind the scenes here. Jaafar and I have actually been working on this for a while. I say we. Jaafar's been working on it. We actually presented this back in, was it January, February?
I'm not the only one. So thanks for everyone who contributed to that effort.
Yeah, definitely a good shout out there. I say Jaafar and I have done literally nothing except watch from afar and watch Jaafar present on this at multiple other things, including back at Tech Exchange earlier this year. So I can take no credit. But yeah, good to point out that, and good to call out that there is a whole team of folks that have been working on it. So with that, I think we're done with top of mind stuff, right, Jonny? So let's go ahead and move over to today's topic. Thank you for the link, Jonny. Appreciate that. So Jaafar, I will hand it over to you, and I want to kind of open up, and I want to ask. So one, I know you've got some slides that we're going to start with, and then we'll go into a demo. But like, what's the terse version of secure supply chain as it relates to Kubernetes and OpenShift?
So can you translate that? The terse, like
short version,
condensed version.
Yeah.
So basically, everybody's been implementing some kind of security in their CI/CD pipelines, things like code scanning, etc., for many years. But one of the key issues that that arose when we've been exposed to things like Log4Shell, SolarWinds, etc., is we can be exposed to things that come outside of our own code and from our dependencies and things like that. So how do we make sure that basically whatever we are bringing also from the outside is something we can trust and something that we can ship along the other components that we have created, for example. And so this notion of a trusted software supply chain is basically piling those new, I would say, safeguards on top of whatever security checks we've been doing before. So of course we can check. So if we speak about I'm gonna dig a little bit into that, and I have some slides that introduce those concepts. But that's, I would say, this notion of a trusted software supply chain is exactly this notion that you can verify the provenance of your components, and that you can verify that they are basically what they claim they are before shipping them into your different environments.
Yeah, and I want to poke at, I think a lot of times we think of software supply chain, and as administrators, we think, oh, well, that's on the developers, right? That's on the app team, that's their problem if somebody manages to get a module into NPM or something that they, include, and it's got a crypto miner or ransomware or something like that in it. And I think that's a very mistaken approach, in that, we've started talking about this concept of OpenShift as an application platform, here within Red Hat, and then a lot of the materials that are going out from Red Hat around that application platform concept. And as administrators, right, we're responsible for helping those application teams, those developers, get access to the tools that they need, right? Making sure that ACS, ACM are available, they're configured correctly, they're integrated in all the ways that they need them to be, as well as, of course, securing the underlying platform. Right? We want to make sure that all of those controls are in place, that all of those, if we have compliance standards or regulatory standards or whatever, all of those are in place. Because, and this goes back to the whole, defense in depth, multi-layered, shift left, all of these other concepts of, it's not just the app team. Even at the software supply chain level, it's not just the app team, the dev team. It's everyone throughout. So it's important for us to have an understanding of what this looks like and where all of those components fit in. And importantly, the things that we might want to look out for. And occasionally, hopefully make some recommendations over to the developers. So, hey, here's how we can do this better. So I won't interrupt you. Sorry, Jaafar.
I mean, the whole idea here is to have a dynamic conversation and not just like going through the tens of slides that we have here. So yes, thanks for setting up the floor, and let's dig a bit deeper into those different concepts. All right, so again, the goal here is to talk about how we can help you implement a trusted software supply chain with OpenShift Platform Plus. So we are going to have two sections. The first part will be introducing what a trusted software supply chain is, some reminder. Then we'll be speaking about some of the main components that play a key role in that supply chain security. And afterwards, we'll be introducing some of the key capabilities that OpenShift Platform Plus provides to support such a trusted supply chain. And finally, we'll have a live demonstration of all of the concepts that we've been introducing along the presentation. So, of course, please feel free to ask questions during the presentation. We can take those on the fly and try to come up with the appropriate answers. If not, then we can get back to you afterwards as well. So what's a supply chain security? So I think we all know what roughly a software supply chain is. And so there are some key things that everyone would agree on, is that we need to have a standardized approach across the organization to deliver the software. So basically taking your application from code to production and having all of those, I would say, standard steps where you basically develop your application, you test it, you deploy it in different environments, you check it for different security safeguards, and then afterwards, once everything is acceptable and you have done your different security tests, your functional tests, performance tests, penetration tests, etc., then you can safely go into production. And so the notion of having repeatable processes across the organization is also something that is important to be able to scale basically your CI/CD pipelines across the organization. So you don't want every single project trying to reinvent how they are going to go over those standardized steps. So it needs to be somewhat repeatable, and we will see how some of the tools that we provide will help in that direction. So the goal is to be able to automate as much as we can from the builds to the tests, the deployments, and make sure that we can safely, like somebody mentioned, say yes and improve those deployments when we have gone through all of these steps. So what's, I would say, relatively new is this notion of what's a trusted software supply chain. And basically, as we mentioned in the intro, people really started focusing on that security as a key pillar in the DevOps approach, and people started talking about a DevSecOps approach, meaning that security is as important. And as you said, Andrew, it needs to be something that is transversal to different teams. You mentioned this notion of an application platform, and the very essence of the platform is that it's going to help many people collaborate on that platform, from the developers to the ops, but also to the the security engineers. And so, for example, if you are shipping a banking application, and there are some standards that you need, the regulatory standards that you need to comply with, then you need to have somebody who understands those and who can help you implement those policies and make sure that, from a functional standpoint, you are also being compliant to those security frameworks or standards, etc. So it's I would say, very holistic approach and collaborative approach. And so some, in the past years, some very specific projects have emerged. And one of those is Sigstore that we're going to be speaking about, which addresses the notion of a trusted software supply chain. So again, as we said, security needs to be holistic and continuous. Of course, we need to implement security within the different steps of the CI/CD pipelines. But let's not forget that once your application is deployed, it continues to live in your different production environments, and you need to have some safeguards as well that will protect you also at runtime. And I believe you had some presentation about those runtime security capabilities presented last week, I guess, with Michael Foster. And we will show you how those can also play hand in hand with all of those security checks that happen with the CI/CD pipeline.
Yeah, and I like that we're putting that in context. Foster last week talked a lot about runtime security and how ACS can watch for, monitor for when or if a pod or a container kicks off a process or anything like that. I think this puts it in great context. So, thank you.
Yeah, sure. So there are several resources that you can use as well. We will publish the links. So there are some couple blogs and the validated pattern as well that helps you, I would say, bootstrap those capabilities in a naked OpenShift cluster to basically deploy the different components, so you can try those as well on your own environments. So speaking about trusted software supply chain, if you've been following Red Hat for long enough and you've attended the last summit, you've probably heard our senior leadership introduce the Red Hat Trusted Software Supply Chain, which is basically a set of services that we have initially created for our own usage to implement those best practices in the way we deliver the Red Hat software to you, our end users. But we also decided to open up that service to some of the, I would say, customers as a first look to be able to play with it, provide feedback. And so basically all of those things that we are speaking about are also part of that, those hosted services that Red Hat has been working on. So basically for both our internal software, but also for you as end users to be able to implement your own CI/CD pipelines with those security safeguards and this notion of a trusted supply chain on those hosted services. So now let's dig a little bit more into the key components that help you implement a trusted software supply chain. And so one of those is Sigstore, which is basically a project sponsored by the Linux Foundation. And the goal is to provide some key components to address those concerns with software supply chain security. And so if we speak about container native pipelines, especially, we know that we are working essentially with containerized applications. And one of the questions is, how can we make sure that whatever container image we are using, we are either as a layer image or as a base image, for example, or if we are using some components that have been shipped from outside, how can we make sure that these are containers that we can trust, that have not been tampered with, that don't have malicious code, or that don't have exploits in them? And so the goal of a component called cosign within Sigstore is to allow you to sign your container images with your own signatures to be able to verify those afterwards. But there's also the ability to sign other types of artifacts. It can sign binaries, it can sign basically any type of artifacts. But especially in the cloud native world and in the container space, it allows you to sign those container images and also store the signed the signature alongside the container image, so you're able to use that afterwards in your verification steps later in the process. So that's a really key step in making sure that it's basically an identity card for your container image that you can check, are you really who you claim to be, before letting that container image into your into your house. And so the second key component is what we call a transparency log, or RECOR. And the key here is to provide a way to gather and store metadata about the artifacts that have been, the software artifacts that have been created, such as their provenance, who made them, when, how have they been built, what components do they ship in them, etc., and be able to store that in an immutable way. So this is a key aspect. So once the software component has been built, we need to make sure that we can keep that metadata somewhere where it cannot be changed. So that's the only way you can verify the metadata against that immutable database that gives us that notion of this is what's been produced at this time by this organization, etc. And you can then use that information to check that the actual asset that you are manipulating in your pipelines, in your deployments, etc., is conformant with the metadata that has been stored in the transparency log once it has been built and stored in there. So that's a key component as well. It's called RECOR, and it's part of the Sigstore project. And so Red Hat, for information, is a contributor to Sigstore, and that's the reason why we are embracing that technology in some of the components that we ship within OpenShift. And so, are there any questions about those before we move a bit further in the explanation of how we use those in our own tool sets?
I have one, but it's more of a
Red
Hat question about cosign and stuff like that. So do you know if Red Hat has packaged up like RECOR and cosign yet? Like I know like before it was still upstream, and we're like I think we're just waiting for it to get like fully like fist bumped before we actually start like making a container out of it.
Yeah. So first, so there are two answers to that. So do we have them shipped as I would say standalone components, supported components in any kind of way? Not yet, but we are actively working on those, and I think the security BU is working on getting some things finished to be able to announce things around those. But we do use them as embedded into some of our components. And so, for example, that's the case for cosign, that we use embedded in Tecton Chains, which is the trusted software supply chain manager for Tecton. And basically Tecton Chains, Tecton, if you're not familiar with it, is a Kubernetes native CI/CD framework. It basically enriches Kubernetes with some CI/CD notions, such as what's a pipeline, what's a task, etc., and basically turns Kubernetes into a CI/CD platform. And Tecton Chains is a supply chain security manager for the Tecton framework. So Cosign is embedded in the OpenShift pipelines, Tecton Chains component that we ship with OpenShift. And the good news is that it's going to be GA in OpenShift 4.14. So it's been announced in the last what's new in OpenShift 4.14 last week, I think. And it's going to be released as GA, so that means you'll be able to use it in your production environment. And so what Tecton Chains does is that under the hood, it does use Cosign to sign the container images and store those signatures in a trusted registry. But it also observes all the task runs, all the pipeline runs that occur, and takes a snapshot, signs them, and stores them somewhere. That somewhere being, for example, the transparency log in the case of Recore. So there's a public version of Recore as a free hosted service that you can interact with, but you can also deploy your own private Recore instance and configure Tecton Chains to integrate with that. And so basically it's going to keep track of all the metadata that has been produced by your pipeline runs and your task runs, and store that, sign that, and store that on the transparency log, so you can afterwards verify the information to make sure that what you are using as the assets is exactly what has been produced by the pipeline. So yeah, it's a key component to add this notion of trust in the end-to-end supply chain. So yeah, I won't go into those details, but if we share the presentation, you will have, I would say, a more in-depth understanding of how that happens. Basically, you generate a key pair that you are going to use to sign your container images, so you can have the private key that is going to be used on your cluster to basically sign the container images with Tecton, and you're going to be able to use the public key to verify the signatures and the container images against those. So as I mentioned, so these are some of the, I would say, technical components that have emerged to be to address those security concerns in a software supply chain. But there's also some best practices, some frameworks that have appeared to help with, basically defining some set of standards around, okay, how secure is our supply chain? How can we make sure that we are providing a certain level of guarantees to our, end users based on the different levels of security that we have implemented in the supply chain. And so one of those frameworks is called SALSA, or Supply Chain Levels for Software Artifacts. And it's basically a set of specifications that go into details about what best practices you need to implement to comply with certain levels of security. It's kind of, sort of the CMMI equivalent for security with regards to your supply chain, to your software assets. So the reason for that is that those security threats can happen at multiple stages of the CI/CD pipeline. And those are some, I would say, prescriptions on things you need to watch and pay attention to at those different steps. So, for example, are you signing your commits? Are you using private repos? Do you make sure that you are using trusted dependencies, artifacts, not artifacts, but repositories, for example, etc., etc. So there are several, I would say, specifications to help you prevent from being exposed to those security threats along the security or the CI/CD pipeline. And so that's, like, I would say, a very high level view of where those security threats can happen. But if you dig into that, it's much more complex than that, and much more, I would say, it needs attention on several fronts. And so if you look at the salsa.dev specifications, it really helps you understand what you need to pay attention to. I think I have some examples after those, so we'll look at it. So another way of having a better grasp of what you are deploying or what you are building in your security, in your CI/CD pipelines, and add some notion of verification, is this notion of software bill of materials. So it's basically a sort of identity card of all the components that you are shipping with your application, and it's like a listing of all the ingredients. When you go to the supermarket and you take any product, you can instantly look at the back and see if there are any things that you don't want to consume or that you are allergic to, etc. And that's basically the same kind of approach. It tells you all of the components that you are shipping in your application, what versions, and you can use that information to verify those specific libraries and check if any of those is exposed to some known vulnerabilities, etc.
So, Jaafar, we've got a couple of questions that I think now is an appropriate time to ask. So, rhope9 asks, so by using UBI as the base, adding some RPM packages from Red Hat, both the base image, UBI, as well as the RPMs would have their own SBOM, which is signed, and signed as the foundation of your own software that you would need to provide and sign your SBOM for. So what I think he's saying there is UBI is signed by Red Hat RPMs are signed by Red Hat. Presumably you would, if you're the development team, the application team, you're writing your own software. If you're creating packages, you would sign those as well in order to have that sort of chain of signatures validating each one of these things. I can also envision where, if I'm an organization who is, adding my own packages, so not just, taking UBI, adding some Red Hat packages, but maybe taking some of my own organization's packages and then installing my application. How does that chain work? And I think that also feeds into Discern's question there about key management and who's responsible for that.
Yeah, so I think that's correct. So you're basically going to layer up things on top of each other, but so we will provide SBOMs for the UBI as such, and we will provide SBOMs for the packages as standalones as well. But if you are laying the RPMs on top of the UBI, I think the safest approach is that you are going to build an output image that is composed of those two, and you are going to generate the SBOMs for those for that output container image. So that's the SBOM that you would be able to sign and verify as this is something that you've built internally. You know that you have the verification for the components themselves, but the the final result, which is your own, the management would be your own responsibility. You would generate the SBOM and sign that with your own keys to be able to verify that afterwards.
Thanks. The second question is from D. Soran, and it's what is the key management / PKI backend responsible for issuing these keys, and who and what is responsible for the key lifecycle management in the event you need to rotate them?
Yeah, so there's a component that we haven't spoken about from as part of the SIG store as well, called Fulcio, and it's basically responsible for those capabilities that you have mentioned. So FULCIO, it's basically a component that has responsibilities for issuing those keys, rotating them, etc. It can also, be used for short-lived keys and such things. So it's been created for that purpose exactly. Instead of having to, manually create your own container images, your own keys, and have to manually rotate them, etc. Because we know that it's not a scalable approach. And so that's the goal of that component. If you guys want to jump in, Jonny, if you have any information you want to add, please feel free to that. So can this be tied into tools like AWS, KMS? I don't know about like an direct integration or an out-of-the-box integration with those. What I can say is it does provide you with some CLIs that you can use. So if you have an ability to integrate that CLI in your workflow, then you can use that. But I don't have an answer as to does it integrate with the AWS KMS out of the box.
Yeah, I just shared the link to is it Fulcio or Fulcio? Yeah. I don't know how to say it.
I say Fulcio, but I'm not sure.
Well, I'll say how you say it, then Fulcio. And I just shared the link to that. And if you go look under the SIG store project, there are a ton. I mean, like there's a ton of projects that they've got going on. Cosign, Recore, Fulcio, and they all do different things. I think Cosign does have the integration with the different backends. I would have to research a little bit more on the Fulcio, but like, yeah, it depends on like where you're talking about. Around if you're talking about like the Cosign stuff, then it looks like there's a lot of integrations that it hooks into.
Yeah, so I'm looking at time and I see the time is flying actually, and we haven't gotten into like the core. So we've spoken about the component, the concepts, and these are also very important, I would say, to set the stage. But yeah, I would like to briefly explain how OpenShift Platform Plus provides those key capabilities so that we can later on understand what's happening within the demonstration. So very briefly, if you're familiar with OpenShift, you know that, as Andrew said, it's a comprehensive application platform that provides services for developers, for ops, etc. But the components we are going to be addressing today or talking about are part of the OpenShift Platform Plus solution, and they basically add multi-cluster management, multi-cluster security, a trusted global container registry, and data management on top of OpenShift. And what we are going to look at is how those tools play hand in hand to provide an end-to-end workflow. And so we've spoken about some of the key things that you need to put in place when you want to have a DevSecOps approach and a trusted software supply chain. So one of them is the standardized software delivery processes. And for those, we are going to be using Tekton, and Tekton, we explained that it's the Kubernetes native CI/CD framework. And afterwards, you need some, and so Tekton is part of OpenShift It's called OpenShift Pipelines. So it's a component that I would say is a productized version of Tekton, which is an upstream project that Red Hat contributes to. But the OpenShift Pipelines is the actual supported and productized component that comes with OpenShift out of the box. And it does integrate Tekton chains as a subcomponent. And as we explained, Tekton chains allows you to sign the container images and store the metadata in a transparency log, such as Rickard. But there's also some proactive security enforcement that needs to happen all along the supply chain lifecycle. And so, for example, you need to be able to scan the container images and see if there are any vulnerabilities in there. So ACS, which is the Advanced Cluster Security solution that you have presented in some of the episodes, allows for that. It generates also vulnerability reports. But the great thing that we are going to see as well is that it integrates very smoothly with the pipeline, and it allows you to have some security gates that prevent any unwanted component, anything that violates a policy that you have defined, anything that is not compliant with some of the security checks that you have implemented, can be acting as a security gate and prevent the application from going into the latter steps of the pipeline. So that's a key component because it's going to help you implement security both at a runtime, which is what you saw, I think, last week, but also at build time and deploy time with the pipelines.
And Jaafar, there's a question here from Nikos, and I think that it'll fit into this section right here, which is, if we pause or stop a pod, and there's some information, some data that's inside of there, right? How do we know whether or not that pod has been modified while it's in that stopped or that paused state?
So,
will the key signing affect that or prevent that, or is that something else?
Yeah. So if the pod has been signed with the appropriate signature, whenever you're redeploying or restarting it, it's going to be based off the same container image, right? So we have things that can prevent that from happening at runtime. So it works basically with admission controllers. And so the admission controller is going to make sure that whenever you deploy the container, it's not going to be able to proceed because it's not a verified container image, for example.
Yeah. So if I'm understanding correctly, when you start a container image, it verifies, and it's basically you're assured that it is starting with that signed and trusted image. While it's running and things are changing and things are being modified, even if you pause it, so it's not a full restart, it doesn't get reset back to zero. Even if you pause it and allow it to run again, that runtime security aspect is handled through other things like ACS, right? ACS
Yes.
is the one that would be responsible for doing that, what I'll call real-time runtime monitoring.
Yes.
As well as the other features of OpenShift as a platform, right? So we trust that things like SE Linux aren't going to mitigate escapes and stuff like that if they happen. But yeah, the key store stuff doesn't mean that while it's running, things aren't changing and it's constantly validating against that signature. When you start it, it is.
Correct, yeah. I mean, it's not when you start it. It's basically a step that you implement in your CI/CD pipeline. It's not something that will happen magically or that is, de facto happening. It needs to happen as a check that you implement in your pipeline. So, for example, you say, okay, I have generated that container image. I have stored it with its signature, and I have created an attestation for that container image. I have the set of metadata that I have stored in Rickard which is the transparency log. At some point, when you want to use that container image, for example, when you want to deploy it, you need to have a step that will verify that the metadata that you have from the container image that you are going to pull from the container registry is the same that you have in the transparency log. So that's when the verification would happen. As to I would say, yeah. So that's what the Recore transparency, or one of the use cases it's used for. But as you said, there are other ways to enforce those runtime security checks, and one of those tools is with ACS.
Got it. Thank you.
Sure. So, yeah, and again, the final component that we're going to see is Quay, which is the multi-cluster trusted container image, which allows you to store signed images alongside their different metadata like signatures, attestations, etc. And also, it also has security features to scan the container images for vulnerabilities. So, let's have a quick look at the demonstration scenario, because I think we've spoken a lot about all of those capabilities. And so the scenario that we're going to show you here is a multi-cluster one where we have basically OpenShift Platform Plus running on what we call a hub cluster. So it does have several components, such as the ACS for security, ACM, the OpenShift pipelines that will run centrally the pipelines before deploying that to regional clusters. So we will have what we call the dev cluster or the integration cluster, and then the production cluster. And the whole CI/CD pipeline will be responsible for orchestrating all of those tools in different stages to be able to implement all of those security best practices in the pipeline. So very briefly, if we talk about the end-to-end process, so of course we are going to have our repository where we store the trusted code. We will have some signed commits in there to make sure that there's some level of trust about what code modifications have happened. Then traditionally you would have your code analysis components. In our case, we're going to be using something like SonarQube, etc. But the things that are, I would say, more relevant to us as to the capabilities that we provide is that we are going to sign the container image with Tecton chains and store that in Quay. But we are also going to be able to verify, sign the deployments, for example. In our case, we are going to be using a GitOps approach. And so we are going to be using some, deployment manifests, etc. And so those are assets that we can sign and verify as well to make sure that we are not deploying our application from an arbitrary tag, for example, but something that we do actually trust. So those are also things that you can sign and verify along your different software artifacts. And remember that the application is made of a set of artifacts. It's not just like a container image. And the manifests that we use are also part of the things that we should verify as well. So we will also be able to deploy the I would say store the metadata automatically with Tecton chains into the transparency log, which is Recore in our case. And at some point in the container, in the supply chain process, we're going to verify that the information we have about the container image is conformant to what we have in the log before proceeding with the deployment into the different environments. So as for the deployment, we're going to be using a GitOps approach. So as part of OpenShift, we also have a productized version of Argo, which is called OpenShift GitOps, and that's the component that we are going to use to be able to deploy that central container image into multiple clusters. Because as we said, we have the dev cluster and the prod cluster that we are going to use as different target environments. Okay, so with that said, I think we can go to the demonstration itself. So first of all, let's have a quick look at the running application. Let me quickly pull a link for that. So yeah, we have those applications that are, a very nice e-commerce application where you can buy Red Hat products. So this is called the Globex e-commerce store, and we will publish the link if you ever want to virtually order some goodies in there. But what's important here is that we have that tag in here that says we are at update version 1, and that's the code change that I'm going to make here to basically show you that we are going to trigger the pipeline and then talk about all of those stages that happen and how the security safeguards are implemented into each of those. So let's go ahead and make a quick change to our code base in here and say, for example, ask an admin. And let's go ahead and stage the changes. Ask an admin update. And let's go to the pipelines first here. So we can see that we have some pipelines that have been run previously, but as we trigger the pipeline here, as we commit the changes and push them to the registry, this should automatically trigger the pipelines. And so we can see here that we have two pipelines that are going to be triggered at the same time. And it's basically to show you two key things. So the first one, we're going to be looking at it, and let's give it some time to finish. It should take 3 to 4 minutes, but luckily we have a previous version that has been run. So the first one is, I would say, a very 101 type of pipeline where we fetch the code, build the container image, deploy the manifests, and deploy the container image. But we see that the final stage of that pipeline has failed some checks. So as we see in here, we have two policies that have been violated. So the first one says trusted signature policy, image signature is unverified. So because we have built that container image with a simple process that doesn't use cosign underneath it, we don't have a signature associated with the container image, and so it did trigger the policy violation, which is enforced by ACS, Advanced Cluster Security. So the nice thing here is that the pipeline is able to talk to the ACS API and have those security gates triggered in case they trigger a policy violation. And so a couple of remarks here. We see that this one has a high severity and that it breaks the build. So that's the one responsible for the build not going forward. And that's basically an option that you can set for your policies with ACS. And there's another one, which is, okay, we have the package manager that has been shipped into the container. This is not a best practice. It should be removed, etc. It does include those two components, micro DNF and RPM. but we consider it's a low security. We decided that the policy, if ever triggered, should not, block the container image from, should not block the process from going forward. So that's basically, an example of how the pipeline can dynamically get data from ACS, security information from ACS, and whenever such a thing happens, you get a nice failure message that explains what are the issues that you get in there. Okay. So, Andrew, have you presented those policies and how they work with ACS, or should I briefly remind how that works in ACS?
Yeah, so I know Mike talked to, and Jonny, help me remember. Mike talked about them, but we did not show them. So
Okay.
it might be worthwhile to show those policies. I know we talked, and we've shown here on the stream before the real-time application monitoring when we prevented, what was it? Was it Heartbleed, Jonny?
Yeah.
I think it was Heartbleed, where in one of the previous episodes with the ACS team, they had shown starting a container image with a known vulnerability and how ACS prevented that from happening.
Okay. So yeah, let's quickly have a look at the one that triggered the break. And so that's the one, the trusted signature policy. Okay. So we see that the trusted signature policy, you have some metadata that you can put in there to describe basically what the policy does, what domain it refers to, etc., or what domain it applies to. And we can see here that one of the criteria is that it should use cosign to verify the container image against a signature that you are providing to ACS. Okay. So now if we go and edit the policy, we can see that there are different things we can define as to the policy criteria. So for example, here we can say, does it happen at build time? Does it happen at deploy time? Or does it happen at runtime? It can happen at all of them. And there's also two options that you can choose in here. Is it an inform or is it an inform and enforce? Okay. And so basically enforcing those policies could break the pipeline as it did with the case that we've seen prior to that. So if we decided that this should not be enforced, then although the policy would be triggered, the pipeline would be able to continue and do whatever it needs to do. So we do provide about 90 policies out of the box, things that check, for example, that your container is not using elevated users such as root, etc. So all of those security policies are come out of the box with the tool. And if I decided to use a container image that has a root user, it will also break the build in my case. So all of those come out of the box with the ACS. But you can then, basically say what are the informations. What's the information that I need to verify? So, for example, here I need to check, for example, that the image tag is or is not something, or that the image age is less than whatever threshold I put in there, etc. So there's a lot of criteria that you can put in there to define your policy, and those will be verified when the pipeline is actually running. So that's how you can implement those safeguards and those security policies into your CI/CD pipeline by combining both ACS and Tekton with OpenShift.
Thank you. Yeah, I think it's really interesting. And I guess the flip side of this is what it looks like from the pipeline.
Yes, exactly. Yeah. And so what it looks like from the pipeline, again, it says there's been 2 violations. And the first one is the trusted signature policy that has been violated. and the chicken, and the
What-
other one.
What does that step look like in the pipeline? Like, how do I create that step, I guess?
Oh, sorry. Yeah, sure. So in the pipeline, there's basically an ACS task that you can use. And so if you are not familiar, I mean, I'm saying you, not you, Andrew, but our public, is that, no, I'm not on the pipelines. I should go to the pipelines. And there are some tasks that we provide. So there's this ACS image check that we provide that you can use. And if we check the definition of the image, it's basically using the ACS CLI, or the Stackrocks. Stackrocks was previously ACS before the acquisition from Red Hat. And it uses the CLI to basically check the data from the ACS API and use that as a decision gate to proceed or not with the pipeline. So it's basically using the CLI that we provide for ACS within the task itself. So those are usable tasks. So if I wanted to create a pipeline using one of those steps, so the nice thing, as you probably know, is that we have this graphical editor for the pipeline. And if I wanted to add any of those tasks, I can use ACS, for example. If I wanted to add a check to verify the deployment manifest, so that's also one of the capabilities. So you can say, for example, I want to check the deployment manifest to see if I have correct health checks defined for my application, if I have, those liveliness probes and all of those best practices as to, having a reliable application. And so I can use that step and add it to the pipeline, etc., very easily, and then provide the parameters regarding the API endpoint for ACS, the secrets that I need to be able to integrate with the API, etc. So it's very, I would say, easy to use within your pipeline because we do provide those tasks that you can consume directly for your pipelines.
And
of course, if you yeah, sorry, go ahead.
So there's a question here from Ross. What is the policy enforcement engine behind ACS? Is it OPA?
So
I don't know if you know the answer to that. I know I pinged over to Michael Foster.
So for ACS, it has its own policy engine that you can use, to create your policies. But there's another component that we haven't spoken about, which is Advanced Cluster Manager, which has, I would say, a broader focus, not just those security policies, but a broader, policy sets that you can apply. And ACM has a capability to integrate with Gatekeeper to support OPA format policies, and ingest them and apply them on your clusters. And it's also compliant with Kyverno policies. So you can decide what type of secure policy solution or specification you want to be able to use, and Advanced Cluster Management extends those capabilities to support OPA and Kyverno formats, basically.
Thank you. Hopefully that answered your question, Ross.
And Jaafar, real quick, I noticed that you're updating the repo. Are you using triggers or are you using like pipelines as code?
No, I was using triggers. It's just a webhook that gets pushed to trigger the pipeline. But there's another component that we can use called pipelines as code, which basically allows you to have the pipeline definition within your application repository. And whenever you make changes to the application, repository, it's going to trigger that pipeline that you have within the application repository. So that allows you to have the pipeline definition going alongside the versioning of your application code itself. So it's a very nice way to be able to have that, everything as code, even your pipeline definitions approach.
This is a shameless plug. I was teeing you up a little bit there. So.
Yeah, thanks. All right. So now let's go back to the more, I would say, comprehensive pipeline, which is the one that we see here. We see that it's also, succeeded. And in this specific pipeline, we're going to instill some more security checks in there and some more, I would say, trusted software supply chain best practices. So we can see here that we are fetching the source code. We scan it using SonarQube or whatever our preferred tool is in there. Here we added an extra layer of verification. We are verifying the commits that have been signed with the signature within the Git repo, etc. But that's the where it gets interesting for us. We are building and signing the container image using Tecton chains. And basically if I go to the task run, build and sign image, build and sign task runs, and search for build and sign the image. Here I should have those two variables in here that say image digest and image URL. These are things that Tecton Chains needs to. So basically, when you define those outputs in there, it tells Tecton Chains and OpenShift pipelines that it needs to sign the container image using the provided signature and store that in the Chraibi registry alongside with the its signature, and it's also going to store that in Rickard. And the way we can verify that is we see that there's an annotation that has been added, Tecton Chains signed equal true, and that means that the test run has been we've taken a snapshot and we've signed that task run result, not only for the application for the task, but also for the pipeline run as a whole. And we have stored that in Rickard for later verification. So let's go back to so I wanted to speak about that notion of signing the container image. Now I'm shifting to Chraibi as our preferred registry, and we can see that we have generated two container images. The first one, which is from the unsigned pipeline, we see that it doesn't have any of those metadata. It doesn't say that it has been signed. If I go back to the other one, which has been produced by the second pipeline, we can see that it has this little tag here that says, so I'm going to, sorry, I think we are a bit over time, but we can see here that the container image has been signed. You can see this little tag in here, and that we are storing the attestation, but also we are storing the signature as well within the registry. So this signature can then be extracted later on by the process or by whichever verification mechanism we want to enforce in there, and be able to check that the container image is actually the one that has been built by the pipeline. So now let's go ahead and go with the other steps. So that was the first one, which is the important one, signing the container image with the signature. The other ones are the integration, again, with ACS. But as we can see here, the checks are passing because we don't have any violations for the policies. And here we are also using a an external tool called Safe to generate an SBOM from our for our application to be able to verify later on that the libraries that we are shipping with the container image do not have any vulnerabilities in them. So finally, if we go back to the pipeline execution, there are some steps here that will use ACS to check the manifests, to check that there are no, again, as I said, no elevated users, nothing that is unwanted behavior in our manifests. And in here we are going to verify.
Jaafar, I'm going to interrupt you there to ask a question
Sure.
that Mirio, apologies for butchering names, asked.
Okay.
So notice that you require a token to be able to authenticate with ACS and execute tasks. Can that be automated for organizations where the developers do not have access to ACS?
Yeah, so there's an API that allows you to generate the tokens from ACS to be able to propagate those to your clusters afterwards.
And Savion asks, what's the difference in your two tasks there between ACS image scan and ACS image check?
Yeah, sure. So yeah, I think we are just so this one will be checking against the policies to see if we are violating any policy in there. The other one is going to scan the container image for CVEs and provide the vulnerabilities report. And it's, again, provided by ACS as well.
Got it. So one's a policy check, the other one's a vulnerability scan.
Yes, correct. And so finally, we do update the manifests in there. As part of the CI/CD pipeline, that's where we are going to integrate with Recore to check that the metadata we have is the actual metadata that we can dig from the image that we have stored in Chraibi. So we can verify the signature, and we can verify that we do actually have an attestation and a proper record in Recore. And then if everything is passing, then we, in the typical GitOps-based approach, we create a pull request. So let me go ahead and check that I do have an open pull request somewhere here that says, yes, production update, ask an admin. I'm going to accept the merge in here. And that should allow us to trigger the sync from the GitOps tool, which is Argo City in here, that will allow us to deploy the application in the production environment. So let me check if it has already updated any of the environments. Yes, so I can see here. So this should be the dev environment, and the latter one we see here should be the production environment that has also been rolled out, because as we can see, we have synced the application manifests with Argo City and updated the application running into the dev cluster. So yeah, that's, I would say, basically an overview of how you can implement all of those trusted software supply chain best practices with container image signing and verification, storing that in a trusted registry with the signatures, with the attestations, and being able to use ACS within your pipelines with the integration that we provide to verify the container images, scan them, check if we are violating any policies, decide if you want to break the pipeline or not, and finally go ahead with the deployment process that is used in the GitOps-based approach, with the pull request being our final approval gate to decide to let the application in production.
Yeah, and I think one thing that you're not showing here, probably somewhere in the GitOps side of things, is additional sets of configuration and all of that other stuff that goes into securely deploying the application, right? This is just to getting to the point where the code is trusted. It has been built from trusted places. We've done sort of the minimum amount of image scanning to be able to use it.
Yeah. So Well, we are doing, the image scanning, but we are also verifying the signature. We are verifying the best practices for the manifest that we update in the Git repository before Argo CD picks up the deployment YAML files, for example, etc. But yes, there's a lot of enforcements that we can apply as well with ACS, such as the runtime. So, for example, if I decided to run an unsigned container image in a namespace, ACS will intercept that and say, "Oh, your image is not signed. I don't allow you to deploy it." So you can have that also happening at runtime, even if the image does not go through the actual pipeline itself. So you can, you cannot hijack or bypass those verifications because you have those safeguards in runtimes as well.
Yep. And there's also all the network policy and SCCs and service accounts, all of the things that also go into actually deploying and running an application.
Sure.
That all come after the image has been built and is ready to deploy.
Yeah, and so all of those are, I would say, out of the box security, best practices, enforcements that come with OpenShift itself.
Yep.
So yes, there's all of those things that you mentioned, SCCs, AC Linux, all of those SecComp profiles or whatever we want to put or enforce for our overall cluster security, encrypted communications, and whatever additional security layers you want to put on top of that. And so I think that's one of the great value props of OpenShift platform is that it does provide all of those security best practices out of the box. So you can build on top of them and not have to reinvent everything from the ground up.
Yeah, and I think we hinted at this at the beginning, right? Of this is sort of one component of a scalable and multi-cluster aspect, right? It's being built here, but because it's Quay and because it's all the same components, right? It's all I'll say verified, in one place. It doesn't matter if you're deploying, in data center A or data center B or in hyperscaler M or wherever it happens to be. It's going to use those same resources and the same things. So that
correct. And the great way of using that as a centralized approach is ACS has multi-cluster support out of the box. So whatever you do can target tens or hundreds of clusters, and it will enforce those policies on them. And the same applies for ACM. We mentioned the policies, the OPA, the Kybernos, and the out-of-the-box policies. All of those are multi-cluster by nature as well, and you can enforce them on your tens or hundreds of clusters with the same approach. So it does provide you with an, I would say, comprehensive way of addressing your multi-cluster security, but also at scale, because you don't have to reproduce that manually for every cluster. You just centrally define what you want as the target, as the final stage, and it's going to apply that as the desired state on all of your clusters.
Yeah.
I think one thing.
Go ahead, Jonny.
Sorry, Andy. I was going to say one thing too, right? Is like each one of these task boxes, right? That's a black box for a solution that might be important to your organization, right? Like it doesn't necessarily just because you have cosign and record. We highly recommend those tools. But there could also be a SonarQube in there. There could also be a whatever, right? Whatever tool that your company uses or has already purchased the subscription or license for. This framework doesn't exclude those tools, right? It says basically like take this little green box right here that says SonarQube and replace it with whatever compatible product that you have that you are already bought into, and then you just add the task to it, and then away you go. So you get the modularity, right? Which is the thing that I think we talk about quite a bit with Red Hat, especially with OPP, right? You get OpenShift and Friends, and then that gives you the ability to like have that okay, maybe I don't necessarily need this piece for this part, but I do for this. And maybe I don't want this for, you know what I mean? Like it just gives you the flexibility to make the solution right for your organization.
Yeah, sure. So yeah, we know that no two pipelines are going to look alike if you take different organizations. And so this is, I would say, a framework that we provide with all those essential steps that you need to implement, and you can build on top of them. As you can see, you can enrich the pipeline, add whatever specific tools you have in there, whatever specific checks. Basically implement your own CI/CD pipeline logic on top of those security gates that we provide.
My thought was, if we're using something like pipelines as code in conjunction with a hosted control plane, clusters as a service type of thing, where Andrew, the developer, I'm going to go out and I'm going to start working on a new feature in my branch. And so I spin up, I have a cluster that's handed over to me, but I still have that central ACS, central ACM using my pipeline as code. Basically, in my cluster, not affecting anything else, I'm able to run through these pipelines. I'm able to build, test, verify, all of these things. It gets pushed back up in, and then if I so choose, or I guess the organization so chooses, using GitOps to then do those pushes out to whether it's dev, test, attestation, right, wherever for the application. So kind of the whole picture comes together at some point there, right?
Yeah, sure. And so I would say, what you said with the pipelines as code is that you also, by defining the pipeline itself as an asset, you add an extra layer of verification. So you have the proper definition. It doesn't live in OpenShift. It doesn't live outside. It lives within your repository. And when you're going to verify the commits, you are going to verify the pipeline definition as well, and see that you are not hijacking anything.
Nobody's skipping a step. Yeah.
Yeah, and you are also you can have bundles defining there, so a static definition of the task, so you know that nobody came afterwards and modified the task definition that the pipeline is referencing, for example. So you know that everything is self contained, and nothing has been tampered with, even the pipeline and the task definitions, etc.
That actually sounds like a fun demo, Sully. I'm just saying, we might want to look into that. That sounds like a fun little demo.
Yeah, and so again, thanks, Jonny, for all the work you've put in there, as long with the many contributors that have worked on it. I'm just the lucky guy who is using the things that the other guys have built as well. I did contribute to some extent, but I want to shout out to everybody who worked on it.
Yeah, definitely. Thank you, because you did do quite a bit, man. Like you're downplaying it a little bit there, but yeah, no, appreciate all your work too.
Thanks.
Oh, I wish I could do it. I'm so jealous.
All right. So yeah, apologies, Andrew and everybody. I think we are a bit over time.
That's okay. So yeah, so Jaafar, thank you so much. This has been very enlightening, and I appreciate that it brings everything together where we can see a tangible example of how OpenShift Platform Plus all fits together, as well as we can kind of see, once I get the application deployed, all the stuff that Chris talked about, all the stuff that Mike Foster talked about, how all of these things come together to give sort of that end-to-end view of what's happening from a security perspective, which of course is just one aspect. So I know we're running a little bit longer than we normally do. Fortunately, my meeting after this got pushed out a little bit, so it was okay. I originally thought I had to drop or would have to end about 20 minutes ago, but you're good. Yeah.
Yeah, I was a bit stressed by the end of presentation because of that. So.
Yeah, no, you're good. So with that being said, thank you so much, Jaafar. So next week we will have the etcd folks on. The week after that is KubeCon. Coincidentally, and Jonny, I don't know if I mentioned this to you. I don't know if the folks who organized this whole thing knew this when we started, but October is also Cybersecurity Month. So, I just figured that out like last week.
Nice. Probably did. They low-key probably knew, and they're like, "Oh, hey, because I came up with."
So thank you very much to our audience. We really appreciate you all joining us today. Really love the questions. If you are not watching us live, just a reminder that you can always reach out to Jonny or I at any time across any of the various places. So I am very simply Sully, Sully, at redhat.com, or Jonny, Jonny, at redhat.com. We're also on all the various social platforms and all that stuff, X, or I typically prefer Slack. Specifically, the Kubernetes Slack is a great way to reach out to us. Every week, look for Jonny posting in there, JRockTX. He posts a link into the live stream in there, so that's a great way to find us as well. With that, Jaafar, I don't know if you have any last words, and then Jonny, I'll hand it over to you for to close it out. Take us home.
Yeah, thanks. Just thanks to both of you and everyone who's been asking those questions, and basically looking at the show for about 1 hour and a half. So thanks for bearing with us, and I hope it was interesting for everyone in there. And Andrew, I guess I'm gonna see you soon. And yeah, Jonny, it was nice seeing you again. It's been
You too, man. You too. Yeah, hopefully we can see each other in person again. That'd be nice. Awesome topic. I think we'd love to have you come back and maybe talk about pipelines and stuff like that, especially from like the infrastructure perspective, how we can use that or dev workspaces, kind of all this stuff together. I think it'd be another cool topic. So, yeah, thanks for coming on, man. Thanks for, I know it's late for you. Thanks for spending your time with us. And to the audience that's watching, thank you very much for all the interaction, because it's
Thanks.
what really makes these things awesome. So thank you very much. And that's
Thanks
it,
a lot.
Andrew.
Thank you, guys. Bye-bye.